Hi everyone. In this video, we are going to discuss about the various types of angles that we have in geometry and trigonometry. I want to discuss all possible angle types here, the angles that we have learned in geometry as well as the angles that we have learned in trigonometry. So now let's first ask this question, can we define what an angle is? Well, in a two-dimensional situation, angle is the shape of the two-dimensional space between two rays that are originating from the same source. For example, I have a picture right here. You see that I have drawn an angle here. There are two rays that are originating from this one source right here. Let me say the source is O right here. Let's say this is a point O. Suppose this is the origin of the two rays and each of them are moving further and further away, meaning from O they are moving away, but the way they are moving, the shape of the space between them is looking like this, and we call that as an angle. And we generally call it a theta. We use the Greek letter theta to denote an angle. So here you see this angle, or the shape of the space between these two rays, is actually looking like an angle. So that is why we say that the angle is the shape of the space, or the shape of the two-dimensional space between two rays that originate from the same source. So now we are going to learn the different types of angles that we have. So the first one we are going to talk about is the acute angle. So let's see how that looks like. An acute angle is an angle which is between 0 and 90 degree. That means the value of the angle should be between 0 and 90 degree. So for example, here I have drawn an angle which is indicated as 45 degrees. So this will be called an acute angle. Acute angles are those angles which are between 0 degree to 90 degree, not more than 90 degree, right? So those are called acute angles. And then the next terminology, or the next type of angle we are going to learn, is the right angle. So what is a right angle? Let's take a look. A right angle is an angle which is equal to 90 degree. It's exactly 90 degree, and right angles are formed by perpendicular lines or intersecting perpendicular lines. So if you have two lines intersect each other perpendicularly, then at the intersection we get right angles. And right angles are denoted like a rectangular symbol like this, the pink symbol right here. So whenever you see a symbol like that, that means it is a right angle. Even if there is no angle value is written there, you can still assume that it is a 90 degree angle. It's called a right angle. Now the next type of angle that we are going to learn is called the obtuse angle. So let's see how that obtuse angle looks like. An obtuse angle is actually greater than 90 degree but less than 180 degree. So any angle between 90 degree to 180 degree, those will be called obtuse angle, and they will kind of look like this. It will be obviously more than 90 degree, meaning it will be larger than 90 degree, but it will be less than a straight angle which is 180 degree. So it will be between 90 degree and 180 degree. So those angles are called obtuse angles. Right? Now the next type of angle we are going to learn about is called a straight angle. So let's see how a straight angle looks like. A straight angle looks like an angle on one side of a straight line. But again, you have to understand here, we are not talking about straight line. We are talking about two rays originating from the same point, but they are traveling in the completely opposite direction. Exactly opposite direction. One ray is going towards the positive side, right hand side, and another one going towards the negative side, which is the left hand side. So if you have two rays traveling like this, then they will be forming an angle which will be equal to 180 degree, and that is called a straight angle. So a straight angle is exactly 180 degree. Then the next type of angle that we are going to discuss about is called a reflex angle. So let's see how the reflex angle looks like. So a reflex angle is actually an angle which is larger than a straight angle but less than 360 degree. So a reflex angle size will be between 180 degree to 360 degree. So here I have drawn an angle which kind of looks like this, and I have noted that it's 240 degree, and because 240 degree is greater than 180 degree but less than 360 degree, this angle will be called a reflex angle. So reflex angle is larger than straight angle but smaller than the complete angle. So the next terminology that we are going to learn is called a complete angle. I already mentioned a complete angle, but a complete angle is actually 360 degree, and let's take a look and see how that looks like. For a complete angle, the angle amount is 360 degree. It's actually an angle which can be drawn around a point. Now in this case, if you are thinking that, hey, do we have one ray or two rays? Actually, we have two rays. For an angle to be formed, we definitely need two rays. But when both the rays coincide with each other after making one full complete rotation, say suppose our terminal side makes a full complete rotation and then coincides with the initial side, then that is when we get a complete angle like this, and the angle amount will be 360 degree. It's actually the entire angle around a point, and in this case the point is the source of the two rays and when the terminal ray makes a full complete rotation and again comes back and aligns with the initial ray, that is when it forms a 360-degree angle, and it is called a complete angle, right? And next we are going to learn about adjacent angles, and let's see how the adjacent angles look like. The adjacent angles kind of look like this, where one angle has a terminal side which is the initial side of the other angle. That means both the angles share a common side. So the terminal side of the first angle is actually the initial side of the second angle, and all the rays, they originate from the same source. And let me highlight this with a green dot right here, that they all originate from the same source, and that is when the two angles that form, let's call it alpha and beta in this example. So alpha and beta, they will be called adjacent angles because they are adjacent to each other. They share a common side, and in this case alpha's terminal side is the initial side of the angle beta. So that is why they are called adjacent side, because they are next to each other. The next type of angles that we are going to talk about is complementary angles. So let's see how they look like. The complementary angles are such angles whose sum would be 90 degree. So if you are talking about two separate angles, like here in the picture I have a 30-degree angle and a 60-degree angle, they are not adjacent, that's fine, but their sum would be equal to 90 degree, right? And then I have another picture where I have shown that alpha and beta, the two angles, they both form a right angle there. They both form a 90-degree angle. So in that case also alpha and beta, they will be called complementary angle, meaning alpha will be complementary of beta and beta will be complementary angle of alpha. The sum of alpha and beta will be 90 degree, and that is when alpha will be called the complementary angle of beta. Similarly, beta can be called the complementary angle of alpha, but their sum will be 90 degree, and those angles are called complementary angles. They could be adjacent or they may not be adjacent. It really doesn't matter, but they will still be called complementary if their sum is equal to 90 degree. The next type of angle that we are going to learn is called supplementary angles. So let's see how they look like. If we have two such angles whose sum would be equal to 180 degree, then those angles are called supplementary angles. So for example, here I have a 60-degree angle and a 120-degree angle. So 60-degree angle is the supplementary angle of 120 degree. Similarly, 120-degree angle is the supplementary angle of 60 degree because their sum is equal to 180 degree. Now they could be adjacent or they may not be adjacent. It really doesn't matter, but they will still be called supplementary angles. And here I have another picture where I am showing two adjacent angles, but again they are supplementary angles because their sum is equal to 180 degree. Because if you think about it, alpha plus beta will be one angle on one side of that straight line, because the two rays are traveling like that, they form like a straight line, and then it will be one angle on one side of that straight line, so that will become a straight angle. So alpha plus beta will be 180 degree, and in that case alpha and beta, they will be called supplementary angles of each other. So alpha is the supplementary angle of beta and beta is the supplementary angle of alpha. And sometimes also it could be called like, complement of alpha, complement of beta. Similarly here, supplement of alpha, supplement of beta. When we say complement, we are talking about 90 degree minus the other angle. When we say supplement, we are talking about 180 degree minus the other angle. So suppose from here we can say, okay, then alpha is actually 180 degree minus beta, and similarly we can say beta is equal to 180 degree minus alpha. In the previous discussion we had alpha plus beta 90 degree for complementary angle. There also we can say alpha would be 90 degree minus beta, and similarly we can say beta would be 90 degree minus alpha. Next we are going to talk about the vertical or opposite angles. I have a picture here. In the picture you can see the two intersecting straight lines. At the point of intersection they create four angles, right? So I have marked them as A, B, C and D. I mean angle A, angle B, angle C and angle D. Now those are the four angles that are created at the intersection of two straight lines. Now angle A and B, they are called vertical angles or opposite angles, and also they have a relationship. Actually A and B, they will be equal. So if you are talking about the vertical angles, they are actually equal to each other. So if you say angle A and B, they will be equal. Similarly angle C and D, they will also be equal. That's the nature of the vertical angles or opposite angles. But what you need to learn here is, what is a vertical angle? Well, it is actually a pair of angles. It's not a single angle, it's two angles, right? Angle A and angle B, they are vertical vertical angles. Similarly, angle C and angle D, they are also vertical angles, and their one property is that they will be equal to each other. I mean, A will be equal to B and C will be equal to D. Now, can we prove that they will be equal? Yes, the proof is very easy. So suppose, let me do a quick little proof here. So suppose we can say, okay, if we look at angle A and C, they both are one straight angle because on one side of the straight line, so they will be 180 degree. So you can say, okay, angle A plus angle C, they are 180 degree, right? And similarly, if you look at angle C and angle B, they will also make 180 degree. I mean, they together, B plus C will be 180 degree because that is also a straight angle, one side of the straight line. So from here we can say, okay, B plus C is also 180 degree. You see the two sums here, this A plus C and B plus C, they both are equal to 180 degree. That means they both will be equal. So if we equate them like this, so from here we can say, okay, then A plus C is equal to B plus C, and from here you see that the C on both sides will cancel out each other. From here we can say, okay, then definitely A is equal to B, and that is the proof that the opposite angles are equal in size, or vertical angles, they are equal in size. Whether you call it vertical angles or opposite angles is the same thing, just two different names, but they mean the same thing, that the vertical angles are equal in size. And this is how they look like. At the intersection of two straight lines, the vertical angles will be created. In this particular example, A and B, that is one pair of the vertical angles, and then C and D, that is the other pair of the vertical angles. Next, we are going to talk about congruent angles. When we have two or more angles which are equal in size, they are called congruent angles. Congruent means they're exactly identical, meaning they're exactly same in size. Their size is exactly same, and that is when we will call those angles as congruent angles. Again, it's more than one, definitely two or more angles will be called congruent angles. So suppose here we have one angle. Let me quickly draw a few angles right here. So here I have drawn three different angles. Even though they look different, they are actually same in size. Each of the angles value is alpha, meaning alpha degree or alpha radian. So if that is the case, then all those three angles will be called congruent angles because they are same in size. So they are called congruent angles. And even instead of saying alpha, if I had said maybe, let's say A and B and C, so suppose the size is, this angle is A degree or A radian, then this other angle is B degree or B radian, and this is maybe C degree or C radian. But if somebody says, hey, A and B and C, they all are equal, meaning they are equal in size, then we can call them congruent angles. Congruent means same in size. I hope this point is clear. Next, we are going to talk about interior and exterior angles. And what is an interior angle and what is an exterior angle, it will depend on the geometric context, right? So now I have taken two examples here. One example for a triangle, we have a triangle ABC, and I have extended the side BC all the way to D. So BC has been extended to D. Now you see the angles which are inside the triangle, like the angle A, angle B, and angle C, because they are inside the triangle, they are called interior angles. And then the angle which is outside, which is the angle ACD or DCA, that angle will be called an exterior angle because in this context, that angle is outside the triangle. It is not inside the triangle, it is outside the triangle, so it will be called exterior angle. And the angles that are inside, they are called interior angles. And similarly, let's also look at the parallel line and the transversal. Here I have two parallel lines with a transversal, and here all the angles which are marked in pink color, they are all interior angles because they are inside the two parallel lines. And then the angles which are marked in green, they are called exterior angles because they are outside of the two parallel lines, right? So that is how we differentiate between interior angle and exterior angle. And also for the parallel line, because we are talking about it, let's also quickly talk about the two other types of angle. One type is called corresponding angles. So here I have seen that angle E and angle B, they will be called corresponding angle. Similarly, angle D and angle G will also be called corresponding angle, and also angle H and angle C, they will be called corresponding angles, and similarly angle A and angle F, they will also be called corresponding angles because those are all equal size angles, right? And they are called corresponding because that is the term used when it comes to parallel lines. And also we have another term called alternate angles. Like for example, if you look at angle A and angle B on either side of the transversal, you see the angle A and angle B, they are called alternate angle because they are on alternate side of the transversal. Similarly, angle C and angle D, they will also be called alternate angles, right? So let me make a note here quickly. I hope you now have a clear idea of what is an interior angle and what is an exterior angle. Again, it will depend on the context. Anything that is inside the shape, they are generally called the interior angles, and any angle outside of the shape, outside of the geometric shape, they will be called exterior angles. Now we are going to talk about positive and negative angles. Now, as you know, an angle can be formed by two rays. So if we have an initial ray and a terminal ray, and if we move the terminal ray in the counterclockwise direction, meaning anti-clockwise direction, then it is going to form positive angles. Like in the first example, I have the white ray as the initial ray in both the cases. In the first diagram and the second diagram, in both the cases, I have the white ray as the initial ray and the light green color ray, that is the terminal ray. So in the first diagram you see that I have moved the terminal ray in the counterclockwise direction and it created a positive angle. Now if you look at the second diagram, there I have moved or I have rotated the terminal ray in a clockwise direction and it created a negative angle. So whenever the terminal ray is rotated in the anti-clockwise direction, it is going to create a positive angle, or those angles will be considered as positive angle as a convention. And whenever the terminal ray is rotated in the clockwise direction, the angle that it's going to form, that angle will be considered a negative angle. So we could have a negative 30 degree. For example, in this case, if I say this is a 30 degree angle, so we are going to call it positive 30 degree angle. Whereas in the second example, if this is a 45 degree angle or 30 degree angle, let's say 45 degree, we need to call it a negative 45 degree. So it will mark it as negative 45 degree because this angle is created in the negative direction, which is the clockwise direction, whereas this first angle has been created in the positive direction, which is the counterclockwise direction. Also in the third diagram, if you see that we have the terminal ray rotated in a clockwise direction, but it has been rotated almost one complete circle, not quite but almost, and we have created an angle 330 degree, and we're going to call it negative angle because the terminal side has been rotated in a clockwise direction. So suppose we started from the initial side and then we kept on rotating it all the way up to this position. Finally we reach a position where we create a negative 330 degree angle. If we assume that this internal angle right here, if we assume that this much of angle is 30 degree, then the exterior angle there is obviously 330 degree because the total will be 360 degree, and in this case this 330 degree angle will be called negative angle because the terminal side has been rotated in a clockwise direction. Similarly, in the fourth diagram, as you can see that we have rotated the terminal ray one full complete circle plus a little more, another 30 degree that we have rotated, right? So one complete circle plus 30 more degree. So we have created an angle which is called 390 degree because its total 360 degree would be one complete angle plus 30 degree more right here. If we assume that this angle is 30 degree, so let me kind of mark it right here. So if this is 30 degree, then the angle that we have created, if you follow the green path here, the green circular rotating path here, you will see that green path has actually created 390 degree angle because one complete angle plus 30 degree more, so that would give us 390 degree. Now whether it's positive or negative, because we have rotated the terminal ray in an anti-clockwise direction, this angle will be considered positive angle, so it will be positive 390 degree. I hope the concept of positive and negative angle is clear now. Next, we are going to talk about coterminal angles, where the two angles having the terminal side as the same side, meaning they both will share the terminal side. So, for example, in the first picture, if you see that we have a positive 30 degree and a negative 330 degree angle, and both the angles have the same terminal side, which is the light green color. So, because both angles are sharing the same terminal side, those angles are called coterminal angle. Similarly, in the second diagram, I have a positive 30 degree and a positive 390 degree. They both share the same terminal side, so 30 degree and 390 degree, they both will be called coterminal angles. And also on the third diagram, as you can see, I have a positive 30 degree and a positive 750 degree. They both share the same terminal side, so they also can be called coterminal angles. Now, if you are given an angle theta, for example, you are given an angle theta, in our example, maybe this 30 degree can be called theta, right? So if we call it theta and then somebody says, hey, can you create a coterminal angle for this angle theta? Then you can say, yep, we can easily create it. Now, how to create it? All you have to do is you have to add an integer multiple of 360 degree. So here we have it like this. So you can say, okay, the one coterminal angle of theta will be theta plus some integral multiple of 360 degree. Right? For example, let's take an example. Suppose in our example theta is, let's say theta is 30 degree, and then if we have to create a coterminal angle for theta, so we can say, okay, then my coterminal angle alpha will be equal to theta plus some multiple of 360 degree. We can start with one multiple of 360, so we can say, okay, 1 times 360 degree, and from here what are you going to get? From here we are going to get, so theta is 30 degree plus 360 degree, that will give us 390 degree. So 390 degree angle is a coterminal angle for 30 degree angle for theta. Theta is 30 degree. So for 30 degree, one of its coterminal angle will be 390 degree. Similarly, you can add 2 multiples of 360 degree or 3 multiples of 360 degree, and then whatever angle value that you get, all of them will be coterminal angle for the 30 degree angle. And that is how you create positive coterminal angles. Now, if you want to create a negative coterminal angle, what's the deal? Well, for negative coterminal angle, again same story, you just want to subtract some integer multiple of 360 degrees. So for example, like on the second part right here, if we say, okay, we have theta as 30 degrees, so in this case let's also take theta as 30 degree, and we want to find out what would be a negative coterminal angle for 30 degree, and we can easily calculate it. We can say, okay, then the coterminal angle alpha will be equal to theta minus, let's start with this 1 multiple of 360 degree. And if we simplify, so theta is actually 30 degree, and we are trying to figure out the coterminal angle or a negative coterminal angle for 30 degree, and that will be 30 degree minus 360 degree. So that will give us a negative, that will be negative 330 degree, negative 330 degree. And I think I have that in the first example right here in the first diagram. That's exactly what we see, that for a 30 degree angle, its negative coterminal angle would be negative 330 degree. Now, if you again subtract one more 360 degree, then it will become 690 degree. I mean, negative 690 degree. That would be another negative coterminal angle for the positive 30 degree angle. So this is how we can create positive coterminal angle or negative coterminal angle. It's very easy. These are the two little formula right here. To find a positive coterminal angle, you simply add some integral multiple of 360 degree, and to find a negative coterminal angle, you simply subtract an integral multiple of 360 degree from the original angle. So in this case, theta is the original angle and alpha is the coterminal angle that we are trying to calculate. I hope the concept of coterminal angle is clear now. Next, we are going to discuss about principal angle. A principal angle is always a positive angle which is between 0 degree and 360 degree. For example, suppose you are given a really large size angle, say suppose 420 degree, right? So somebody says, hey, I have an angle 420 degree. What is the principal angle for this angle? Well, the principal angle will be 420 degree minus some integral multiple of 360 degree, so that ultimately we can bring it down to a range between 0 and 360. So in this first example, as you can see right here, if we are given an angle which is greater than 360 degree, I mean greater than positive 360 degree, then its principal angle can be calculated as the original angle minus some integral multiple of 360 degree. So our first example, we took original angle as 420 degree, positive 420 degree angle, and then its principal angle will be 420 degree minus some multiple of 360, so that the value comes within the range of 0 to 360. So in this case, I am subtracting one multiple of 360, so that the final answer becomes some angle value. In this case, it is 60 degree, which is within the range of a principal angle. Principal angle is always between 0 degree to 360 degree, and its value will always be positive. If somebody says, hey, I have a principal angle which is a negative value, that's totally wrong. Principal angle is always denoted in positive. It's never negative, right? So no matter what angle you have been given, you either subtract some multiple of 360 degree or you add some multiple of 360 degree. For example, I have a second example here. When you are given a negative angle, for example, suppose you have been given a negative 520 degree, for example, and you have been asked to calculate the principal angle for this negative 520 degree. Now, what would be the principal angle? Well, because it's negative, you want to add some integral multiple of 360 so that you can bring it back to a value which will be within the range of 0 to 360. So in this case, what I did, since we have negative 520, I thought, well, I need probably two positive 360s to bring it back to a value which will be within the positive range between 0 and 360. So I said, okay, the principal angle for negative 520 degree will be negative 520 degree plus 2 times of 360, and that gives us a 200 degree angle, and that is the principal angle for negative 520 degree. To calculate the principal angle for negative 520 degree, what I have done, I have added 2 times of 360 degree with the original angle negative 520 degree, and then finally we are getting a value which is 200 degree, and that is quite satisfactory to be a principal angle because it comes within the range of 0 to 360. 0 to 360, within that range, if we can calculate an angle by adding or subtracting any integral multiple of 360 degree, we can easily calculate the principal angle. So in the second example for the negative 520 degree angle, the principal angle will be 200 degree. I hope the concept of principal angle is clear now. Next, we are going to discuss about angle in standard position. This is very important for trigonometry. If an angle is denoted on the Cartesian coordinate plane having the initial side along the positive x-axis and the vertex at the origin, so those are the two key points we need to remember, right? The initial side has to be along the positive x-axis and the vertex has to be at the origin. Then this angle will be called an angle in standard position. Now, why it is standard position? Because we are starting at the origin, initial ray is along the positive x-axis and the terminal ray is wherever it needs to be, right? So in that case, this angle will be called an angle in the standard position. Next, we are going to talk about angle in a specific quadrant. Now that we are talking about angles on the Cartesian coordinate plane in standard position, now in this particular example, the diagram that I have here, this angle theta, this angle is in the first quadrant. Why? Because on the Cartesian coordinate plane, we know that this is the first quadrant. So let me make a quick note here. And then this is the second quadrant, and then this is the third quadrant, and then this is the fourth quadrant. The Cartesian coordinate plane is divided into 4 quadrants. The first quadrant is the top right portion of the plane, that is the first quadrant, and the second quadrant is the quarter which is on the top left side. Third quadrant is the quarter which is on the bottom left side, and fourth quadrant is the one which is on the bottom right side. Now, if you have an angle in standard position and the terminal ray of that angle is located somewhere within the first quadrant, then the angle will be called a first quadrant angle. Like in this particular example, I have the angle theta, its terminal ray is within the first quadrant. So this angle theta in this particular example will be called a first quadrant angle. Now let me draw a second quadrant angle. Now in this example, as you can see, this angle is greater than 90 degree and the terminal side of this angle is located somewhere in the second quadrant. So this angle will be called a second quadrant angle, meaning it's obviously greater than 90 degree but less than 180 degree. So it will be called a second quadrant angle. Now let me draw an example for the third quadrant angle. So here we have an example of a third quadrant angle which is larger than 180 degree but smaller than 270 degree, and the terminal side of this angle is located somewhere in the third quadrant. So this type of angles will be called third quadrant angle. And similarly, let me draw a fourth quadrant angle. Now in this example, as you can see, the angle that I have here, theta angle, it's actually greater than 270 degree but less than 360, and the terminal side of this angle is located somewhere in the fourth quadrant. So this type of angle will be called a fourth quadrant angle. So depending on where the terminal side of the angle is, the angles will be called accordingly, right? If the terminal side is in the first quadrant, we are going to call it a first quadrant angle. If the terminal side is in the second quadrant, then we are going to call it as a second quadrant angle. Similarly, if it is on the third quadrant, it will be called a third quadrant angle, and if the terminal side is on the fourth quadrant, then it will be called a fourth quadrant angle. Next, we are going to talk about quadrantal angles. Now, when the terminal side of an angle coincides with one of the axes. For example, if the terminal side lands on the positive y-axis or negative x-axis or negative y-axis or even positive x-axis. In those cases, those angles will be called quadrantal angle. So what would be those angles then? Well, clearly you can see if the terminal side is along the positive y-axis, then that angle will be a 90-degree angle. If the terminal side is along the negative x-axis, then that angle will be a 180-degree angle. If the terminal side is along the negative y-axis, then the angle will be 270-degree. And if the terminal side coincides with the initial side along the positive x-axis, then you can call it 360-degree or maybe 0-degree. If you want to take the principal value, then it will be 0-degree, otherwise you can call it 360-degree. So those angles are called quadrantal angles. Now we are going to talk about the concept of reference angle. When you have an angle which is greater than 90-degree, we try to find the acute angle that its terminal side creates along the x-axis. Whether it's the positive x-axis or negative x-axis does not matter. However, with the x-axis, if the terminal side creates an acute angle, that acute angle will be called the reference angle. So a reference angle is always greater than 0, less than 90-degree. Let me make a quick note here. So at the top I have made a note that the reference angle will be greater than 0-degree and less than 90-degree. And it is always a positive value and it is always an acute angle. So now in this example, if you see, I have an angle which is 120-degree, theta equals 120-degree. Now if we have to find the reference angle for this 120-degree angle, well, first we have to find out where its terminal side is, and obviously terminal side will be in the second quadrant because the angle is greater than 90-degree. It is 120-degree, so the terminal side will be on the second quadrant. Now if you look at that terminal side and either of the x-axis, whether it's the positive x-axis or negative x-axis, you try to find one of the x-axis and the terminal side of that angle to see if it is creating an acute angle. Now here to find out, well, I can clearly see that the negative x-axis and the terminal side, which is the blue line, they are creating an acute angle. So that acute angle will be called the reference angle for 120-degree. So for the 120-degree angle, the reference angle will be this angle which is between the negative x-axis and the terminal side of that angle. So if you are given an angle like 120-degree, what would be the reference angle then? Well, clearly it will be 180-degree, which is a straight angle, minus the angle itself. So that's the calculation I have done right here. To find the reference angle for 120-degree, what I have done, I have said, okay, it must be 180-degree minus the angle itself. Then whatever we are left with, that will give us the reference angle for this 120-degree angle. Now for various angles which could be located in different quadrant, we can use these three little formula right here. So if an angle is a second quadrant angle, to find its reference angle, what we need to do? We need to simply subtract the angle from 180-degree. That will give us the acute angle between its terminal side and the negative x-axis. Similarly, if there is an angle which is on the third quadrant, meaning its terminal side is on the third quadrant, to find the reference angle for that angle, what we have to do? We have to subtract 180-degree from that angle, and that will give us the acute angle between its terminal side and the negative x-axis. So if an angle is in the third quadrant, meaning if its terminal side is in the third quadrant, then all we have to do is we have to subtract 180-degree from the original angle to calculate the reference angle for that angle. And then if the angle is in the fourth quadrant, meaning the terminal side of the angle is in the fourth quadrant, then to find the reference angle, we have to subtract the original angle from 360-degree. That will give us that little acute angle between the positive x-axis and the terminal side of the angle. So drawing a quick picture is very handy. No matter what angle you have been given, try to locate the terminal side, and then all you have to do is you have to mentally figure out whether you need to subtract from 180-degree or whether you need to subtract 180-degree from the angle, or whether you need to subtract the angle from 360-degree to find the reference angle. I hope the concept of reference angle is clear now. Thank you for watching. See you in the next video.